Okay, so let's talk about different upwelling zones. So first, let's look at different zones that exist on the continental shelf. So in this sketch, you can see the continental shelf. You have an inshore region, okay? And the inshore region is actually the zone where the surface and bottom layer overlap. You have a zone where the layers are separated, the surface and bottom Ekman layer. We call it the mid-shelf region. Okay. And then we have a slope region where it's near the shelf break, where you have an oceanic influence. And they actually play an important role, because what it means is there a source of nutrients, a process that actually brings deeper water, which has higher nutrient levels, onto the shelf? Okay, it's a preconditioning process. Okay, because what the upwelling process does on the shelf, it only lifts water from, say, 100 meters or so into the euphotic zone. And it all matters whether this water is actually nutrient rich or not. Okay, and that's why I gave you that definition of upwelling, because you can have upwelling, but if there's no nutrients in the water that you bring into the euphotic zone, nothing will happen. Okay, so here, what are these different zones? In the slope region, oceanic influences are in. And there are different types of oceanic influences. One, for example, is interactions with submarine canyons, with shelf break canyons, that can induce a localized upwelling of deeper water across the shelf break. Or you can have a process which is called dynamic uplift. It's to do with the large scale shape of the nutricline, and if that can be also lifted across the shelf. Okay, so in the mid-shelf region and also the inshore region, what really matters is the longshore wind component. And you'll see in the next lecture is also the upwelling. If you create an upwelling cross-shelf circulation, which means offshore Ekman transport near the surface, onshore Ekman transport near the bottom, it actually reaches into very shallow water, this circulation. So also in the inshore region, you need to have longshore winds in order to bring nutrients into this region. And that's a very, very important to understand. Okay, this is very, very important to understand. And this principle shown here only works away from the equator. If you're closer to the equator, the thickness of the Ekman layers actually increases. And so that at the equator, there's no Coriolis force at all. Okay? All right.